We can also extend from the previous video and solve the two-dimensional wave equation. So that is phi squared, day squared phi by day t squared being equal to c times del squared, I think this is c squared, phi. Okay, so if we set our domain, that is delta x and delta y being equal, say h, then we have the following formulation. So phi I j n plus 1 minus 2 phi I j n plus phi I j n minus 1 divided by delta t squared is really equal to c squared over h squared multiplied by phi I plus 1 j n plus phi I minus 1 j n plus phi I j plus 1 n plus phi I j minus 1 n minus 4 times phi I j n. Okay, and now if we set the condition that c squared delta t squared over h squared is equal to a half, and note that this is the maximum value for stability, this term, then we can derive the following from this equation, that is that phi I j n plus 1 equals to a half multiplied by phi I minus 1 j n plus phi I plus 1 j n plus phi I j minus 1 n plus phi I j plus 1 n minus phi I j n minus 1. Or you can write this in type of matrix form, that is phi I j at time n plus 1 is a half multiplied by 1, 1, 1, 1, and 0, phi I j n minus phi I j n minus 1. Now, for our first time step, we use the initial condition at n equals 0. So at n equals 0, we say that phi I j minus 1 is given as a half multiplied by 1, 1, 1, 1, 0. It's just an easier way of writing it. Phi I j at 0 plus delta t times some mapping function of x and y. Okay, and again, our initial conditions must be specified. So phi x, y, 0 being equal to f of xy, and then we have phi of t x, y, 0 equal to g of xy, and boundary conditions of phi length in the x domain yt being equal to phi 0 yt, and lastly phi of x length in the y domain t equal to phi x 0 t. Okay, so I'm using the subscript t here, and what that really refers to is the gradient. So hence, if you look at this g function is the same as this one. So if we take the derivative of, say, day phi by day t multiplied by delta t gives us the change in phi, which we can then apply here to get this initial value. Okay, and just a last point, that when we use this method for the 2D wave equation, we don't end up with exact values. And we also require, in general, smaller time steps in relation to the space interval.